So in this problem, we are asked to set up the triple integral in cylindrical coordinates to find the volume of that part of the sphere. So we're given a sphere that lies inside this cylinder. Okay, so this here is a sphere centered at the origin with radius let's say r is equal to 2, right? So that would look something like this. Okay, and then here the radius is 2. So set up the triple integral in cylindrical coordinates to find the volume of that part of the sphere that lies inside the cylinder. Okay, so let's see what are we talking about right here. This is x squared minus 2x plus y squared is equal to 0, right? I'm just bringing 2x on this side, and this is what I just have to complete the square. X squared minus 2x plus 1. If I add 1 on the left hand side, I'm gonna add 1 on the right hand side. Okay, and this completes the square. This is x minus 1 squared plus y squared is equal to 1. In R2, this is a circle with radius 1 centered at 1, 0. So right here. Okay? And in 3D, right, in R3, X, Y, and Z, so this is a cylinder, and then it extends. As you can see, Z is free, right? So Z can have any cylinder like that. Okay, so if we plot the sphere and the cylinder in one coordinate system, so as you can see, if this is 1, then this is 2 here, right? Because the radius is 1, okay? And this here is 2 because the radius is 2, so it's something like this. And then the same thing here. So this looks something like and then this part here is the part of the sphere. And the same thing happens here. So I have to find the volume of this. So the volume is just the triple integral. So it's in cylindrical coordinates. So the Jacobian is r, dz, dr, d theta. Okay, so z runs from here all the way to here, right? Now that means that if you express z, if you isolate z, is going to be 4 minus x squared minus y squared, or z squared is equal to 4 minus x squared plus y squared. X squared plus y squared in cylindrical coordinates is r squared, so 4 minus r squared. And then taking square roots on both sides, we are going to get positive or negative z. And then bringing on this side, you get z is equal to positive or negative square root of 4 minus r squared. Okay. So obviously z runs from negative square root of 4 minus r squared to square root of 4 minus r squared. Okay, and that's the bound for z, right? So from negative square root of 4 minus r squared to square root of 4 minus r squared. Next is the r. Okay, so when we're using cylindrical coordinates, the bound of r can be seen in these polar coordinates. Okay, so where does r go from? It goes from 0, right, all the way to the circumference of the circle. Okay, so how to find what is r? What is r bounded by? Obviously it's bounded by this circle, and the equation of the circle is right here. So let's take this equation and express it in polar coordinates. Okay, so you have x squared minus y squared, x squared minus 2x plus y squared is equal to 0. Express everything in polar coordinates. So you have r squared cosine squared theta minus 2r cosine theta plus r squared sine squared theta is equal to 0, right? This is y. This is 2x and this is x squared. Factor out these two, you get just r squared cosine squared theta plus sine squared theta minus 2r cosine theta is equal to 0. This is just 1, so you get r squared minus 2r cosine theta is equal to 0. Factor r and you have r minus 2 cosine theta is equal to 0. So when is this 0? Where either r is 0 or this factor here is 0, implies that r minus 2 cosine theta is 0 or r is equal to 2 cosine theta, which is something that you should be aware of, something that you are accustomed to. This is nothing else but the equation of a circle along the x-axis. So r is bounded by 0 and 2 cosine theta. So r is bounded from 0 to 2 times cosine theta. And the final part is what theta is bounded by. Okay, so theta, here you have to be careful. We discussed this quite a lot when we learned about polar coordinates, is that this circle is completed when theta goes from 0 to pi, not to 2 pi. Okay, be careful. So when theta is 0, right? So this is the circle. We just express the circle in polar coordinates, 2 cosine theta. When theta is 0, r is 2. It's right here. Okay. When theta is pi over 2, cosine of pi over 2 is 0, so it's 0. So that pi over 2 it already comes here. Already comes here is the circle. And when theta is pi, so when theta is all the way here, right, cosine of pi is -1 times 2 is -2, so drops on the other side, and that's how it completes the square. So theta, sorry, not the square, that's how it completes the circle. So theta goes from 0 to pi, from 0 to pi. And this is how you set up the triple integral in cylindrical coordinates of this solid right here, okay, needed to find its volume. Next problem, we're given a vector function and we have to, in part A, I have to sketch r of t. Okay, so what can I recognize? That x is equal to 2 cosine t y is equal to 3t, and z is equal to 2 sine t. Okay, so from here, x squared plus z squared, be careful, is equal to 2 cosine squared t plus, sorry, not 2, but 4, my bad, plus 4 sine squared of t, which is simply equal to 4. So z squared, x squared plus z squared gives me what? A is equal to 4, which is nothing else but a circle in the xz plane with radius 2. Okay, so in 3 dimensions, that's gonna look like this. Right, this is 2 and this is here 2. But then, as t goes from negative infinity to positive infinity, y extends, goes from left to right. Right, so this is y, this is x. So we can get the helix. Let's see where it starts to be as precise as possible. When t is equal to 0, x is equal to 2. When t is equal to 0, z is equal to 0, and y is equal to 0. So we start from here, right? And then we go when t is pi over 2, let's say when t is pi over 2, cosine of t is 0, cosine of pi over 2 is 0, and this is 2, so then it comes here, so it's like this. And that's the orientation. Okay. Part B, we have to find the velocity. This is very simple. The velocity, the acceleration, and the speed. So the velocity is equal to derivative of t, something that we learned even in Cal 1. That's negative 2 sine t. Derivative of 3t is just 3. Derivative of 2 sine t is 2 cosine of t. The acceleration is a derivative of the velocity, or simply the second derivative of the vector function. So that's negative 2 cosine of t, 0, and negative 2 sine of t. And finally, the speed is equal to the norm of the velocity, right? The speed is velocity without the direction, which is the norm of r prime of t, which is square root of a negative 2 sine t squared plus 3 squared plus 2 times cosine t squared equals to 4 sine squared t plus 9 plus 4 cosine squared t is equal to square root of, obviously here, 4 sine squared t plus cosine squared t plus 9. Sine squared plus cosine squared is 1, so that's 4 plus 9, and that's square root of 13. Okay. Next is find the equation of the tangent line to this curve at pi is equal to t is equal to pi over 3. So somewhere here, let's say, I need to find this tangent line. Okay. So C, the equation of the tangent line is the equation of any line in R3 is xyz is equal to x naught, y naught, z naught, which is a point on the so this is a point on on the line, and this is a vector parallel to the line. Okay, so what is going to be the point of the line? Well, that's simply r of pi over 3, right? So that's this point right here. How are we going to evaluate this point? We're going to evaluate this point when we're going to evaluate r of t at the given value of t. And the vector parallel to the tangent line is nothing else but the vector r prime evaluated at pi over 3. Okay, so let's do both of them. So r of pi over 3. Now this is just a point. That's 2 times cosine of pi over 3. 3 times pi over 3. And 2 times sine of pi over 3. And that's the point. Cosine of pi over 3 is 1/2, so that's 2 times 1/2. These two cancel out, so just pi. And 2 times sine of pi over 3 is square root of 3 over 2. So you get 1 pi square root of 3. That's the point. That's the point x naught, y naught, z naught. And now r prime, that's the vector parallel to the tangent line, evaluated pi over 3, is the vector, well, we evaluated it right here, right? Negative 2 sine evaluated pi over 3. Then just 3. And finally 2 times cosine of pi over 3. Sine of pi over 3 is square root of 3 over 2, so negative 2 times square root of 3 over 2, 3, and cosine of pi over 3 is 1/2, so 2 times 1/2, that's negative square root of 3, 3, and 1. So finally, the equation of the tangent line is, depending whether you want to use this notation or this notation, is the same thing. So the point on the line, that's 1 pi square root of 3 plus t times a negative square root of 3, 3, 1. Or of course the same thing, you don't have to bother too much with this. You use the notation that you prefer. It's the same idea. And finally, the last question is to find the curvature at t is equal to pi over 3. Now there are two main formulas, ways to evaluate the curvature. It seems here appropriate because we have already evaluated our prime and our double prime. It means seems appropriate to use the norm of the cross product over the norm of, or the speed, right, at pi over 3 cubed. Okay, so the norm, first of all, r prime at pi over 3 is what? Is right here, negative square root of 3, 3, 1, cross product. R double prime, or the acceleration, is negative 2 cosine of t. Okay, here I can say that a of pi over 3, or r prime of pi over 3, is equal to negative 2 times cosine of pi over 3, that's 1/2, 0, and negative 2 times sine of pi over 3 is square root of 3 over 2. So that's negative 1, 0, negative square root of 3. Okay, so that's the second derivative evaluated at 1, and I'm going to write that right here. Negative 1, 0, negative square root of 3 over, and this is the norm of r prime of 3 evaluated pi over 3, and as we can see, the norm of r prime is constant, square root of 13, so that's square root of 13 cubed. Okay, or that's simply 13 square root of 13. Okay, so let's figure out what is this cross product. Negative square root of 3, 3, 1, and negative 1, 0, negative square root of 3. So that's 3 times negative square root of 3, negative 3 square root of 3, right? Minus negative square root of 3 times negative square root of 3 is positive 3, minus minus 1. Minus minus 1 is plus 1, and finally this is 0, 0 minus negative 3. 0 minus negative 3 is positive 3. So that's negative 3 square root of 3, negative 4, and 3. And now if I want to find the norm of this, that's square root of 9 times 3 plus 16 plus 9, which is how much? 27 plus 25, that's 52 if I'm not mistaken. I don't know, you guys check whether I made a mistake or not. Let me do that again. Seems correct to me. So this is equal to, the norm is square root of 52 over square root of 52 over 13 square root of 13. Now square root of 52 can be written as 4 times 13 over 13 square root of 13. Square root of 4 is 2 times square root of 13 over 13 square root of 13, and finally you can make this expression nicer. That's gonna end up being 2 over 13.